Our next speaker, you all know him. I asked him if he would give a talk on the future of programming, and no response. So then, a little while later, I asked him again, hey, what do you think about doing a conference? He was like, I'm in. Yeah, sweet, but a little more detail, please. And so I really don't know the topic of this, but I trust David because I've seen probably all of his talks, and they are consistently epic and well presented. And so without further ado, please welcome David Nolen.
Last talk, hopefully it's mostly fun. This talk is called CLJS.main, or the JoyVs. It's kind of a code archaeology talk, but then, acting on, understanding the history of how we ended up, and then kind of trying to solve the problem. But specifically, I think I want to demonstrate here at the end that, I think Clojure is a very powerful tool. It's simple. We know this. I think that's why we enjoy using it for work. But also, I think that it's been 9 years or something. I've been using Clojure since 2008, and ClojureScript, of course, is almost 7 years old. So I think it's a good time to think about how we can take that same, really actually think about ease. Like I would say that Clojure, when you use it, it's simple, but it also is pretty easy. I think that's why we like it. RUPL and stuff. I think we could do a lot more around tooling to make tooling actually significantly easier to use. I would say it suggests that actually right now the tooling story in Clojure, while it's fine, I mean it's just it's as good or better than what other people are doing. But I think as a community, I think we could show that there's a much better way to do it than everybody else is doing it. And I think I'd like to demonstrate a step in that direction. So let's get started. So this is the contributor graph for ClojureScript. So the last 6.5 years. There's lots of spikes. I mean, activity is consistent, but we get these huge areas of development. Of course, you have the initial push at Relevance. Relevance is now Cognitect. Rich and 10 people at Relevance worked on ClojureScript for about 2 or 3 months before they released it. There's another huge spike here in the summer of 2015. That's when I allowed optional bootstrapping of the compiler. The compiler can compile itself to include JavaScript. So that's how Plank and Lumo, which are becoming quite popular, because there's very fast startup time, but you get most of what you like about Clojure. They all work on the bootstrapability of ClojureScript. So another big dev push there. There was another big dev push in the summer of 2017, and this is an ongoing story, which is just that Google Clojure itself, we rely on Google Clojure for advanced compilation, but Google itself wants to be able to consume dependencies from Node. So they had built support for this, and we simply wanted to make that easier for ourselves, and we piggyback on that support. Now there's 2 other big areas of activities, and that's the one I'm actually going to talk about. This one here, which we'll get to in a second, and this one here. So Eric is right. To be honest, I didn't really know what I was going to talk about, and I started working on a new feature about 2 weeks ago. And at first I thought, oh, this is just going to be a simple thing. It's not a big deal. It's certainly not talk-worthy. And it turned out, I think I just finished up a first version of it and got some feedback from other ClojureScript developers. And I think actually there is something here that's bigger. Even though what you're going to see is simple, and you probably think, well, it should have always worked that way, which is true. There are some missing things, and again, I want to show that this is a pattern that we can adopt as a community, and I think it will make everybody's lives easier. But let's start at the beginning. Lisp. Before I get into that. No, but seriously, there's a big point here, which is that this is one of the greatest books ever written, I think, fiction or nonfiction. It's amazing. If you haven't read it, you must read it. It's really good. But for me, it was my first introduction to Lisp, and for me, the really stunning thing about Lisp, I actually was studying this book right at the same time I was learning how to play Go. I'm an avid Go player, and the thing I like about Lisp is that you can explain Lisp to somebody in the afternoon. And you know, when you get to the part in the book about the metacircular validator, you think, oh, this is going to be some crazy complicated thing. And the fact that, you know, in a couple hundred lines of code, you can have Lisp defined in itself, you can change the semantics. I mean, it's so cool. Like, you know, certainly it's not something I would ever imagine doing, because I'd come from a background of like, you know, doing a little bit of Java or C++. I never would have thought in my mind that most of the power of programming languages is easily described in Lisp, and you can really play around with it, which is really cool. But that's another point, that actually Lisp, this is just a slide showing that I used a PLT scheme when I went through SICP, which is a really great environment. And really, I think that's something that I think has always been true about Lisp. Lisp wasn't just simple, right? When McCarthy sat down to make it, he was really annoyed at how people program computers. It was so tedious, it was so error-prone, right? So not only did he invent, you know, all these great things like interpretation and symbolic manipulation, but he wanted a programming language that was easy to use. You type a thing into the computer, and the computer immediately gives you a response. That programming should be interactive. So ease was always a part of Lisp, but I think that it is an important quality to maintain. I agree with Richicki in that simplicity, you've got to go simplicity first. I mean, if you start with ease, then you end up in the messes that you tend to see, but I think that ease is an extremely important goal once you handle the simple part. And so I read this book, and I was shocked. You know, I read this in like 2003, SICP, and I was like, this is the most amazing thing that I've ever seen. Everybody must be using this, right? And then you go and look, and you know, there wasn't that much Lisp activity. Certainly not paid activity. I mean, there was, but it's just, of course, it was hard to find if you didn't know where to look, and certainly not the level that your mainstream languages have activity. So I sort of set that aside for many years, and then I was getting like, you know, curious about Lisp again, and I was like, well, what's going on with Lisp these days? And I happened to come across the website, the Clojure website, and the thing that was really great was at the time I was struggling with SBCLs, Steel-Baked Common Lisp, I guess. And at the time, it's actually easy now. Much easier to get started with Common Lisp. But in 2008, it was actually really hard. It was just like fiddling around with Emacs config and just trying to get Slime to work. And I was like, man, this sucks. This is so hard. Lisp is great, but why is this so hard to do the simplest thing, which is write programs in my editor? And then what was really cool about Clojure was that I clicked a link, I got a jar, and that was it. I could get a REPL. And I didn't have to do anything. And on top of that, I was like, okay, this is really cool because it runs on Java. I mean, I can imagine one day, I could actually imagine myself using this for something because people want Java. I mean, so much of the work out there is JVM based. So Clojure for me became a kind of hobby language. So I was happy that I had the power of Lisp and I had a relatively easy system to use. Of course, it's easy to get started. So the thing I'm going to talk about is that it's one thing to say it's easy to start, and there's so many other things that you have to work on to make a programming language easy for the average developer. So it's not just, do I click a link and I download and I can run it with the command line, but does it have text editor integration? How do I manage dependencies? And there are all these questions, and they've been answered in various ways. I would say actually these days, the editing story is pretty good, and then of course thanks to things like Cursive, if you really want that full-blown IDE experience, Cursive is quite good. But Emacs support has gone through the roof. If you don't like nREPL, like the inferior Clojure support is through the roof. If you want to use Visual Code, Atom, whatever. This is the editing support is quite good, quite nice. And that's great. But I would say that the dependency story and the tooling story, there's more work to do there. And I think there's a way to improve on that. We'll see that. But so ClojureScript was announced in 2011, and they had done basically the ClojureScript story is quite different because when Richicki did Clojure was a traditional Lisp in the sense that compilation and evaluation are sort of interleaved, right? You're inside the JVM, you're compiling code on the fly, you're loading on the fly, and that actually makes a lot of things easier for the Richicki as the developer of the language. ClojureScript was quite different because we were compiling to JavaScript. Evaluation cannot happen in the thing that's doing the compilation. Evaluation must happen somewhere else. And so there were, this is like, I would say the last 6.5 years was like, well, how do you make this feel like Clojure if the compilation evaluation model is so dramatically different from the way that Clojure works? And so we're going to dig into that a bit. So making ClojureScript easy took a far longer time. And I think the stuff I'm going to demonstrate, I think, is definitely a huge step in the right direction there. So ClojureScript for me was super exciting because again, Clojure was just a hobby for me. I was doing open source stuff, but I was doing JavaScript. A lot of front-end work at the New York Times. When ClojureScript came out, I was like, okay, now I'm going to definitely get on this bandwagon because it has a direct impact on the type of work that I do. So I started contributing heavily to ClojureScript. Again, Rich Hickey did the right thing. He did the simple thing, was like, well, if we're going to do or target these, web-based clients, you really don't want to ship like tons of JavaScript. If you do Bootstrap first, then you're going to be like, the dependency is at least going to be 300K of JS to download to the client. That's just that. By using Google Clojure, it can be as small as 20K, right? And that's a huge, huge, huge benefit. You can load tons and tons of dependencies, and Google Clojure will ensure that you get a reasonably sized thing. But again, this also presented a challenge. That meant that like lots of things that Clojure has, like vars and like all this stuff, Google Clojure expects your JavaScript to be written in a very specific way that makes it very easy for it to statically analyze and do its optimizations. And we generate that type of code. But that means like we couldn't do the typical Lisp in JavaScript where again, it's like an evaluator, it runs in the browser. We couldn't do that because we wanted to, again, to generate compiled JavaScript that could be optimized by Google Clojure as a second pass. So the the typical simple evaluator thing, we couldn't really do that. So that actually, again, that made challenges. So people had to understand Google Clojure. So again, the onboarding process for ClojureScript, I think, was quite challenging. Relevance tried to deal with this. Brent and Ashworth specifically, they had this thing called ClojureScript 1, which was just a project to show people that ClojureScript was approachable, and actually Google Clojure was super useful. People just had never heard of it before, right? Most people outside of Google don't care about Google Clojure. And in fact, I would say, in many ways, ClojureScript itself has really increased the visibility of how powerful Google Clojure is and how much functionality Google has poured into it. The compiler, of course, but then Google Clojure Library, it's like 300,000 lines of JavaScript that they know runs everywhere, right? It's battle tested, right? All the way back to IE6, which is awesome. It's not our problem, it's Google's problem. Another step to try to address the ease issue with ClojureScript was Lighttable. Lighttable was a fantastic project by Chris Granger, and it really was awesome. Lighttable itself was written in ClojureScript. You could basically start ClojureScript and be inside and evaluate inside of Lighttable. And that was really, really, really cool. And a lot of people, I think, started trying ClojureScript because finally there was a way, just by downloading a text editor, that you could try ClojureScript. It was really great. But again, it sort of shows that there was a fundamental issue, is that ClojureScript itself wasn't that easy to use. You had to go somewhere else to feel like you could be productive with it. And that was a problem, but we had many other fish to fry. So it took a long time to deal with this. But you really saw this, all right? This is the survey from Clojure 2014. So ClojureScript was already 3 years old, right? So ClojureScript had this issue. It really had this issue because Rich got to do Clojure for 2 years. Nobody even saw it, right? Nobody saw that version of Clojure for 2 years where he was just getting the thing working. ClojureScript was quite different. I mean, I would say that the first 2 years of ClojureScript was basically like the first 2 years of Clojure. It should have been invisible because it was a bit of a mess. I'm happy that people tried it out, but there was just so much work to do. But it shows here in the survey, people would say that like 31% of users, and this survey was like, 1,560 people responded, but 31% of the people that use ClojureScript didn't even use a REPL. That's like nuts, right? A Lisp, they're using Lisp and they're not using a REPL. Can you imagine somebody responding this way to Clojure? No, right? So there was definitely a problem. And again, the issue here was that some of these problems were simply because Rich chose a good design decision, but that created many technical challenges. Because fundamentally, the truth is that trying to do something with JavaScript it is a Rube Goldberg machine, right? It's really hard. And this boils down to evaluation has to happen somewhere else, and that could be a web browser. So that means we can't even get real values from that thing. We have to serialize, and generally it's just going to be a string back from that other environment. So that creates lots of issues for making a REPL and experience that's equivalent to Clojure. So you can't get directly at values, it's sort of serialized to string. There's no reflection because you can't be in that thing, right? Compilation happens in Clojure, not in the JavaScript environment. And then there's JavaScript runtime differences. So yeah, okay, Firefox and Google Chrome, they all follow the spec. But the thing is, nobody says anything about like what do stack traces look like, right? So every JavaScript engine prints stack traces differently, right? They're not the same. And then there's just tons of impedance mismatches because everybody wrote all the pre-existing Clojure tooling assuming you had I can eval and compile in the same process. Like that's going to happen in process. And a lot of tooling assumed this, and that's just not true. So people were frustrated, but the truth was that Rich made a decision which made this was a big impedance mismatch. And so it took a long time for tooling to change how it worked so it could be adapted to the way that ClojureScript works. So the thing I want to talk about, which will lead into the last half of the talk, is there was a huge REPL refactor. So something else, this was in 2015, so ClojureScript was already 4 years old. And at that point, we were pretty happy with Clojure as like, okay, you can compile it, you can ship it. People were particularly excited at this time because React had been out for a year, and everybody was switching to React with things like Omen and Reagent, and people were like, wow, this is better. You also had things like Big Wheel, which is huge. I mean, like I think now surveys say that almost 70% of ClojureScript users just use Big Wheel. Maybe it's even 80%. But the problem was that the ClojureScript REPL was something that wasn't really finished. In early 2015 or late 2014, it still wasn't finished. Brenton and Stuart Sierra and some other people had worked on it, but it was very basic and it did not emulate Clojure, right? So you couldn't really compose with the way that Clojure REPLs worked, right? So tooling assumed a thing about Clojure REPLs, but ClojureScript didn't match it. So it really was probably, I would say, the one massive breaking change that happened, and it really broke tooling for about 3 months because it just needed to be fixed. And it took a while. Fig Wheel, fortunately, fixed the issue pretty quickly, but it took a long time for other things like nREPL and Piggyback to catch up to those changes. But in the end, it's water under the bridge. It was the right thing to do, and well, I'll talk about some cool things you can do with it in a second. But just to show you the difference, this is the REPL method, the REPL function in Clojure. Half of it's a doc string. I think it's only 50 lines of code. And this is the one in ClojureScript, which does the same thing. There's no doc string here. And a lot of this is just because we can't eval. You can't call eval. Every time we want to do something, we have to eval a form. It has to be passed to the JavaScript engine. We have to get it back and then do something with it. So just bootstrapping the REPL just takes way more work. But in the end, it was huge, right? So we did this, and at the time, Mike Fikes was helping me with the design of the API. So we built a fully generic REPL infrastructure such that you could, in about 200 lines of code, for any JavaScript target, build a REPL. And all it demands is how do you get the code to the JavaScript environment and how do you get it back. Everything else we automate. Ambly is a REPL for JavaScript Core, which is Apple's high-performance JavaScript engine that runs inside of Objective-C, but iOS. So he wanted to dev iOS with ClojureScript, and he built a REPL on top of the existing architecture. No crazy hacks at all. It's about 500 lines of Clojure, and you can basically launch an iOS application, and over Wi-Fi, you can REPL into the iOS thing. No Xcode is required, and we use WebDAV, and so you can compile to a folder, and WebDAV does the same. So the experience of developing iOS is exactly the same as the browser. And this was, again, source mapping. So we have fully generic source mapping, meaning that we actually have code so that when an exception is thrown in the JavaScript environment, we have a whole set of protocols to correct that and present a normalized stack trace which shows locations in your sources, not in the compiled JavaScript sources. It's, again, completely generic. We have stack trace mapping for Firefox, for Chrome, for JavaScript Core, Nashorn, Rhino. And then anybody can do a new one, and it's maybe 15 lines of code. It's pretty cool. And then, of course, Fig Wheel. Fig Wheel was huge, right? So, people have talked about live programming for years, and it's, large, to me, as far as I'm concerned, it's largely been an academic discussion. And Fig Wheel, by limiting the scope and saying, because we're doing functional programming, live programming can be practical, extremely, extremely practical. We can reload all definitions, and because we treat state as an immutable value, live programming in ClojureScript, it just works, right? Because we avoid all the issues that mutable languages have, which prevent hot code reloading from working well. And I think anybody that's used Figwheel is like, you definitely don't want to go back to the way you were doing it before. It's really cool. But one of the huge benefits of that refactor was that ClojureScript REPLs, now since they work just like, since they work just like the Clojure REPL, you can actually launch a socket REPL. So when I dev, I actually launch a socket REPL and I can run Figwheel. And socket REPL doesn't care how the thing works as long as it works like the Clojure REPL. For example, I've launched Figwheel on an EC2 box and I SSH in from cursive, like with a tunnel, and I actually can have Figwheel live loading code on a remote machine, and that's pretty freaking cool. And so there's the good part and the bad part. The good part was, okay, all this stuff works and people were able to build really great tooling, but the thing was that for the end user, even though Figwheel works great, Ambly works great, for the end user, it still wasn't that easy. I would watch people struggle. I'm like, why doesn't Figwheel work? Why doesn't it work in Emacs? Why doesn't it work in Vim? Whatever. And and when they finally got working, they were just like so amazed. And they were so happy, and of course they'd go off and be productive. But to me, that whole process of trying to get a REPL working in ClojureScript was still like trying to climb a mountain. Who wants to do that? Some people want to do that, but that's a small population. Most people are perfectly happy to go onto a nice hill on a nice day. You did something nice, right? I want ClojureScript to feel like this. It's cool. Some people want to climb mountains, but I want the experience to be like, I went on top of a nice hill on a nice day, and it was really fun. And that's what the second half of the talk is about, making ClojureScript fun in this way. So about 2 weeks ago, I started on this thing called cljs.main. Again, I started it, and I was really thinking, it's just a nice thing that we need. It's not a big deal, but I actually think it is a big deal. So cljs.main is basically replicates ClojureMain. So ClojureMain, so if you don't know, if you launch Clojure, the jar, you can say ClojureMain, you can pass a bunch of flags. And we now support all the flags, except what we do is we evaluate in whichever target JavaScript requirement you want to run it. Why didn't we do this sooner? Clojure had main since the beginning. Why didn't ClojureScript have main? A lot of it actually boils down to the way that we work with Google Clojure, right? So the compiler could compile files without namespaces. You could do this, right? But what Google Clojure itself couldn't do anything with it because those files wouldn't have Google required. So we didn't prioritize this because Google Clojure couldn't really use it in the build. So we fixed this because we wanted data readers to work, which is not going to get into that, but we needed it because data readers don't have namespaces. So I was like, let's just fix this problem. So we now have a way to compile files without namespaces and have them be included in the build, and it just works the REPL and all this stuff. Also, you had to have an NS form to declare your dependencies on other libraries, right? And so it wasn't possible to write require. Right? You couldn't just write require or a series of requires. This is no longer true. You can actually write requires and imports and whatever in a file, and you don't need the NS form. We actually have a new type of NS form just for this case. And so that means you can write scripts that have no namespaces and have requires, and it just works. But you need this in order to do ClojureMain, because what do people do with ClojureMain? They run scripts that have no namespaces. They just run to the user NS, right? The other reason we didn't do this sooner is because, to be honest, everybody was pretty happy with the fact that there was another tool that could let them do what they wanted, whether that was Lightning Boot or Maven. And so, people were using that, so we didn't really spend that much time. Though I think now that I see the possibility for tooling to greatly improve, my opinion about this has changed. I really think that tooling should be shipped as libraries, and you should have no dependencies on other sort of tooling frameworks. And then another thing was, it just wasn't obvious that the heavy lifting was already done. So when I sat down to work on this, I was like, oh, this is going to take me a month. And it turned out that all the work that we did on REPLs basically was all that was required to make ClojureMain work as expected. I was stunned. The core part of this is only like 20 or 30 lines of code to emulate main. So we support all the Clojure options, a -e, and the way that Clojure works, you can have any number of expressions that can be interleaved or whatever. You can -e and you pass the things you want to evaluate. -i your init scripts. -e and -i can be interleaved again. A -m, which is the main, like which function do you want to call, and in that namespace you have a -main function in there. and it will invoke that with command line arguments. This works. You also have -r, that also works. Didn't include that here, but that does work. And then we have things that ClojureMain doesn't do, which we support basic compilation. Meaning that you can pass, there's an option -c to compile a namespace, and that supports a bunch of other things like -o to say what's the output file, -d to say what's the output directory, -w for if you want to watch a directory, -o to say I want to use this level of closure optimization. So you can do all basic compilation just from command line flags. You don't need to write these config scripts. The really cool thing is -re, which says what JavaScript environment do you want to target? So that's the REPL environment, whether that's iOS or whether that's Node or Rhino or NAS or whatever. That's the environment that's going to actually do the evaluation. So you can supply this. And the way that I designed it, we'll get to that in a second. Out of the box, we support Node, NASORN, Browser, and Rhino. That's always been true, but those are the ones you can use from ClojureScript by default. And then what I said was, this is Lisp. We're just going to make this pluggable. Right? So the way that we do it is we actually, all we care about is, if you do -re, we simply look for a namespace called cljs.repl, dot whatever that evaluation environment is going to be, and then we just load it, and we find the thing, the constructor, and we call it. So anybody can write their own new REPL, and all you have to do is include a dependency, and then you can use it by the main. So Figwheel actually, Bruce is working on it, so he's already tested it with Figwheel. You can just run Figwheel, just add a dep, you can just run it. No configuration, no other tooling. It just works out of the box. Mike Fikes tested with Ambly, which again is the iOS REPL. It already just works. So you can launch Ambly and connect to an iOS device. So let's see a demo. It's going to be, this is a very slow laptop, so I apologize, it's not going to be particularly fast, but still, I think you'll still see the value of it. So here I'm using CLJ, the CLJ tool. You could of course go, download the Django, Java, CP, whatever, but I'm just gonna do it this way. So I'm gonna say I want to run something in Node, and I want to add some numbers, and this will take a second. It's a little laptop too. But that works. And here I have a file that has no namespace. That works. Clojure supports dash, and you can read from standard in. That works. And then, let's do something more interesting. Actually, let me show this. So the other cool thing about depseed and tools deps is that there's all this awesome support for aliases, right? So I've defined an alias and all this extra stuff. I can say all these command line arguments are assumed if I do node. So, if you haven't tried depseed, you should definitely try it. I think it's a game changer. But what I'm demonstrating here is that what just happened, like ClojureScript itself is a tool. I don't need anything else, right? I don't need other stuff. Like that's how it should work. It's just a namespace with some functions, and I have a way to call it from the command line. So here I'm going to go, actually let me touch this file. Okay, and then I go clj-browsers, just the boilerplate flags here. And I'm going to compile, I'm going to go -v. I'm going to say compile foo.core, and then I'm going to launch a REPL after it's done compiling. Oh, I forgot something. Let's make this slightly more interesting. Boom, right? That's how you want it to work. So this, I think for I work at Cognitect, right? Like Cognitect people are like, how do you use ClojureScript? And it's like, it's true, it's hard to use. And I think this is what we want. It should just work like Clojure. So whatever you know about Clojure, use ClojureScript. It's just the same. It should be that way. So again, so what would it look like if you were going to do fig wheel? So this doesn't work yet, but just in your depth-eating file, you'd make an alias for fig wheel, and you just have extra dependencies when you're running this alias, and you put your boilerplate command line arguments here, and fig wheel is just clj-a fig. That's it. Right? It's just, as long as anything is just shipped as a regular old library, this is going to work. I think Cognitek just announced a thing called Test Runner, which is just like this. And like now with like depth-eating, you can be like, oh, somebody just made a new library, and I want to run it as a command at the command line. And you can just do git deps and get it, and it's just available to you. I think this is how tooling should work. It's just a regular dependency. It's just extending the class path, and you're just invoking some function and passing some command line arguments. I think that's the right way forward for a majority of tooling. Again, today, Mike Fikes said this just works, right? So ambling. All you got to do is include that as a dep, and boom, he's hacking Lisp on his iPhone.
Probably my battery died, so I'll just talk louder. So it's just, the tool has extensible command arguments. You can augment this. If you want, I don't think many of you are going to do this, but like Figwheel does more stuff. It has things like build IDs and all these other things. So you can actually, the system that I built, it's extensible. So Figwheel can do all these things also from the command line and actually add more options if it needs it, because it probably will. And again, the big idea here is a plugin is just a Clojure. Plugin is just a Clojure namespace that defines the REPL environment. But again, I'm saying we should take it further. But this pattern is something that we could use for a lot of our tooling. So just to wrap up, I think Clojure is a really nice instrument. It's a beautiful instrument. It's simple. It can take a lifetime to master, but it really is truly expressive. And I think now, with things like depth-eating and like cljs.main, I think as a community, we can all focus on making, also easy. It's actually valuable and important, especially if we want more people to try it and be successful. That's it.
Wow, thank you. So when I learned that there is now a one command installable Clojure install, and you just had one command, I was kind of curious why now? Why were they doing that? Could you shed some light on that?
Yeah, so tool steps was just because internally, to be honest, I stopped. There's nothing against line of groups, right? But I stopped using those things years ago because I would constantly encounter issues with my own project. So I would just use Maven. I don't like Maven, right? I do not like Maven. But I was like, it's a known quantity. If I need to look something up, I can go find that answer on Stack Overflow and go on with my life. So at Cognitek, we encountered this constantly, where we would be on a client project, and inevitably something was weird about the way they were using Lightning or Root. And again, those tools are designed to help people and whatever, but because they're pretty complex now, they actually do a lot of stuff. It's easy to get in a situation where you don't understand these things. And so we avoid them internally. But the thing was, avoiding them internally made it. Who wants to do that? And so Bridge was like, we got to fix this, at least for ourselves. And so he had Alex Miller do a design based on his ideas, and that became tool steps. And then they pushed it out. One thing that drove it also was spec, right? So the problem was that once spec was introduced, they split the jar, like the artifacts. We needed a dependency tool. That was a hard requirement once they did that, because it used to be Clojure was shipped as one big thing, but when specs got split out, you had to have a dependency. So a bunch of things that caused this to be like suddenly prioritized. But at the same time, I think it wasn't clear, and I think it's going to become more clear as people adopt it, that this is a better way. This is a better way.
Okay, great. I'm actually looking forward to exploring it. I haven't needed to yet, but I do see what it is. Do we have any questions? Oh, okay, sure.
You want a card?
No, just shout it out.
Mind your name. all of this is great. I've been loving testing. The whole idea of having libraries rather than a specific implementation for your field is awesome. One thing I have run into in looking at how to make things portable between Boot and Lanigan, in particular, is that Boot and Lanigan will assume a particular namespace for like line templates, for example. And I'm seeing hints that there could be similar things with cljs.rebel. Blah, blah, blah. What if there are two different implementations for RebelNet or Node, for example? And who gets, you're not in control of that that namespace. And if there are, how would you?
So it's not a pattern that I would suggest. It's not like a generic pattern that I would suggest depending on the namespace. But in this case, there's only 3 serious REPL world.
Right.
So
I'm saying I'm looking at the new one.
yeah, but I'm saying just pick a name. I mean, the chances are like you're really going to pull in a depth that defines a bunch of REPLs. I mean, if that's happening, something is wrong. but I agree, it's not a pattern. You should not. Namespaces should be unique, and I would not suggest doing this trick in your tooling.
So we have another question from an anonymous person. Did you just kill Plank and Lumo?
No, so that's
so what's their remaining value?
It's a great question. So, I mean, the thing is, you saw it's like, even though this laptop's slow, it's never going to be as fast as Plank and Lumo. It's never going to be as fast. If you're doing Unixy stuff, or like things that you normally do as Bash, I think Plank and Lumo are really good at that. And internally, everybody loves Plank and Lumo. I mean, there's no desire here to compete with those things.
Yeah.
What would be the difference between using FigWheel and using
So
Repeat.
yeah, the question is, so FigWheel is the live coding REPL that people use, that people really like for doing browser stuff. And the question was, how is that different from just watching a directory? So Watch doesn't hot code reload. So FigWheel is very smart. When you change a file, it hot code reloads that file, but also knows what the graph looked like, and it finds those things and it reloads them in order correctly. So it just does more things. FigWheel is also just highly configurable in a way that does more things. Again, you can have different build IDs, like one for dev, one for prod, and all this stuff. ClojureScript doesn't do any of that stuff. It's just the basics. So
What does -w do?
it just watches the directory and recompiles.
Recompiles the files that changed.
That's it. But it doesn't reload. It doesn't reload.
Yep.
Does it make sense to have a CLJS tool now that just kind of runs CLJ and defaults to cljs.main? That would have done it.
You could do this, so it's already been suggested. I mean, there's nothing wrong with that idea. That was like the first, once everybody saw it working, was excited about it in Slack, a lot of communication happened there. People were like, we totally have a CLJS tool. The one thing that I'll say though, probably what's going to happen is that there's this thing called prepl in Clojure, which most people probably haven't looked at, but they actually cut 1.10 alpha just with prepl, and prepl is a new kind of REPL. It stands for programmatic REPL, and it's a REPL that does a really awesome thing in that the way that REPLs work is that you're generally out in error, right? So if you run some expressions, then what's going to happen is the output's going to be interleaved when you're printing, so you can't actually understand, you can't use the output stream. You can't use it. So prepl changes that. So it takes a reader, but it outputs a map. And the map is the sequential response. For each form that was read, it gives you back a map with the output, or the error. So it's distinguishable now. And like a lot of things that people wanted to do, you could do. For example, you could build a tooling REPL, which passes in a thing which has like a form, and you can know, oh, we don't need to print this one back out. You can read it back and be like, this was the programmatic thing I wanted to do, and I don't need to print it to the user. So what I'm really excited about is to do the ClojureScript prepl. And then I actually think something that's going to be really powerful is that you can imagine a tool that lets you say, I want to switch into Clojure and do stuff there. Because that's actually really useful. So I can imagine a standalone CLJS tool, and I think it has utility, but I think there's some power here to be able to do something in ClojureScript and also do something in code.
How does what you just said relate to the work that Bruce Harmon is doing on his ClojureScript or whole stuff?
So he wants this. So I was like, he wanted to do it away like over the existing REPL, and I think it's a bad idea. I was like, just wait for PREPL. I'm going to implement PREPL, and then Figwheel can do things like autocomplete.
But it's the stuff that he's been tweaking on the whole system, is that what you're saying?
So I don't know how this thing works, but he's struggling, I think, to get the behavior he wants, and I think he should build his thing on top of PREPL, and then all those problems go away.
Do you foresee a standardization of aliases? So that basically in the future you grab a Clojure 110 project and you don't have to think about anything, you run CLJ, alias dev, or anything like that? Or will it be wide open so you always have to introspect?
So, I actually haven't messed with it. I suspect with aliases you actually need to, you have to ask Alex. I would say that's another reason to try DevSeeded is to, there's going to be problems or issues like, well, do aliases themselves, is it better to namespace them, or should they be voided in project DevSeeded and all this stuff? There's all these questions that I think need to be sorted out, and I don't have a good answer because I haven't thought about it.
Are the aliases, where are they defined?
So you just define it right in your DevSeeded file. So down here, alias. So this is my global DevSeeded. This is my dot .go directory, my home directory. But you can define them in your local DevSeeded too, which is actually probably for aliases generally a better idea, but I just did it here.
Cool. And that gets installed when you install the CLJ?
Yeah, when you install CLJ, you get to dot .clojure directory.
Any other questions? You have them right here.
Last talk of the day.
Yeah. We're all tired, aren't we? Well, I'm going to end it if there's no more questions. Right.
When's it coming out?
So what's really cool is that we'll probably do a release in, probably in just a week or two. There's another thing I want to do, which is an optimization. So we'll probably start doing global caching of your jar depths. So that should be a huge speed up the compile time. So if you compile something in a jar, then we're never going to compile it again. We're going to do it once. That's huge because when you do cold builds, recompiling depths are not changing. We're going to wait. So that's probably going to take a couple weeks, but that's it. That's the last thing I want to get in. But another thing is, everything I demoed right now, you can use DevSeed and supply the Git shop. You can supply the Git shop and you can try this out. It's never been easier to try ClojureScript. You can literally write steps and that little expression would be like the this version of ClojureScript from GitHub, and just write try it out. I definitely recommend it. That part, just to be able to try out libraries with the Git depths, it's awesome.
Well, thank you, David. Thank you so much for all your work and for this presentation. Thank you so much.